Here's a great place where sensing the difficulty and knowing that we're in the hard section of the test can really save us 10 points because it forces us to prove our answer instead of taking a shortcut that might make us fall for a trap. So I don't trust my instincts here. That's the moral of the story, is this is supposed to be a hard question. So if I look at this and read it and have an instinctive kind of response and pick an answer right away without doing any work, that's not a good sign. No matter how strong that instinct is, it's not a good sign. We're in the hard section of the test. It's very likely that they've written the question in a way to take advantage of your instincts. So you just need to pay attention. Sometimes instincts are good. We've seen that in other parts of the exam, other sections, earlier in the math sections. But we need to know when to doubt our instincts. And that is this is definitely a place where we need to do that because it's supposed to be hard. So maybe our instincts are right. But we don't know. We don't know. We might be falling for a trap and not know it. And so we need to be careful. So what I would do here is I would arithmetize, right? I don't want to have to think about this algebraically because my brain is not good at handling algebraic logic. It's much better with numbers. So let me show you how that would work here. It gives us this equation, and that models the number of members of a gym T years after the gym opens. Okay. Of the following, which equation models the number of members of the gym Q quarter years after the gym opens? So we're converting the formula. So we probably know that quarters is going to be 4 times however many years, right? If it's 2 years, we would say that that's 8 quarters. 2 times 4 is 8. If it's 10 years, that's 40 quarters, right? 10 times 4 is 40. So that's logical. But let's just pretend for 1 second that we only have 1 year, something that's very easy for us to understand. If that were the case, then we would have M equals 1800, not 18,000, times 1.02 to the first. Right, so that's something I could even put in my calculator. 1800, 1.02 to the first is just 1.02. So in that case, M would be 1,836. So based on the question, if the exact same amount of time passes, I should end up with the same number of members, right? That's the whole point of this, is that I'm measuring the exact same thing, but I'm using a different unit of time. But if the same amount of time passes, I should have the same result. And I chose 1 because it's a nice and easy number. Now, when I go to the answer choices, I've got to choose a new number because I don't have T in the answer choices, I have Q. But I know that 1 year is 4 quarters. So the value of Q, in this case, is going to be 4. Because when Q is 4, T is 1. 1 year, 4 quarters, it's the same amount of time. So I plugged 4 in 4Q. So in that case, choice A would be 1800 times 1.02 to the 4 over 4. So even without my calculator, I know that that's going to give me the exact same value because 4 over 4 is 1. So look, this equation reduces to the same equation that I had above. 1800 times 1.02 to the first. I'm not even going to bother entering it. I know it's right. This is going to give me 1836. So that's a good sign for choice A. If I did the same thing to choice B, 1800 times 1.02 to the 4 times 4, well, again, I don't need to put that in the calculator to know that 1.02 to the 16th is a very different number than 1.02 to the first. How different? Let's see. 1.02 to the 16th is 2,471. Huge difference. Big difference. That's what exponential growth does, right? The more the time passes, the faster it grows. So what's going on here? Well, this is the trap answer. I would say that 95% of the students that I have that get this wrong, they pick B because their brains, their instinct, is that you take the number of years and you multiply by 4, right? That's what I was saying before. If you have 2 years, 2 times 4 quarters is 8 quarters. If you have 10 years, you multiply that by 4 to get 40 quarters. So the logic makes sense. 4 times the number of years gives us the number of quarters. But that's not how these equations work. We're not trying to find the number of quarters. We have the number of quarters, right? So we're trying to kind of work backwards from that. And when we use the numbers, it's indisputable. It's indisputable. A is going to be the answer here. Now I could do the same thing with C and D. I'm not going to get the same answer. The problem with these choices is that we've changed the percentage. So things aren't going to work out the same way. Maybe choice D will get me close. Let's see. Times 1.082 to the fourth. Nope, that's also super big. So all of these answer choices, this is 2,467. 1,800 times 1.005 to the 16th is 1,949. So it's only one. But this is my point, is we need to pay attention to where we are in the test. This is not hard if we arithmetize and take, 60 seconds to prove our answer right. And that 60 seconds is absolutely worth it, because the alternative isn't that you follow your instinct and get it right in 10 seconds. The alternative is that you follow your instinct and get it wrong in 10 seconds. So yeah, you saved a bunch of time, but you lost the points. Well, there's no reason for that. Especially because arithmetize, one of our best strategies for the SAT when the algebra gets confusing, it works here very easily. We have a calculator. There's no reason not to just take the seconds to do this. Absolutely worth it. You have to get stuff like this right. If you know what you're doing, if you're thinking strategically about the SAT, this is an easy 10 points. If you're just pretending it's another math test, you just lost the points for no good reason. And that's not going to be good for your overall score, because they're going to do this exact strategy to you, this exact tactic, again and again and again. So we got to be on top of it and pay attention to where we are in the section so they don't fall for these kinds of traps.